All right, in section 4, we're going to factor and solve polynomial equations. You've factored and solved trinomials, so this is, of course, the same thing, only just one step harder. For step 1, you're going to factor out a monomial. And then step 2, you're going to either use FOIL or recognize a pattern. And then the reason number 3 is in red is that's when we start solving. So to fact, what we're going to do first is we're going to factor these expressions completely. Now remember, if it's not an equation, you can't solve anything. So we're not going to solve it, we're simply going to factor it. And step 1 is to factor out a monomial. So we've got y3 minus 4y squared minus 12y. So we look to see, is there anything in common in all of these? And we can say, yes, there is a y in all of them. So let's factor out a y. And we have left y squared minus 4y minus 12. And then we look to see, well, will that factor further? It's not a perfect square, but let's see. So can we do FOIL? We're looking for, remember, our y times y is y squared. We're looking for two numbers to multiply together to get 12. And then we're going to add them together to get the 4. And if this is a negative, that means one is positive and one is negative, because these two need to multiply together to make a negative number. So if we use 6 and 2, then we have negative 12, and we have negative 6 and negative 6y, and positive 2y gives us a negative 4y. So that's how we factor those out. Let's do another one. These are still trinomials, but they're with larger, we're calling them polynomials because they have larger exponents than just our squared terms. But in this case, again, we've got x's in common. We can pull an x out. And we've also got a common coefficient of 3. So we can pull out a whole 3x out of each one of these. So I said 3x and then I didn't do it. 3x. And then what's left here is x squared. What's left here is 10x. And this is 25, and there is no x left. And so then I can look and see, and hopefully you've remembered those patterns, because this is a perfect square and a perfect square, and the middle is the square root of this doubled. So we've got a squared plus 2ab, or a squared plus 2ab plus b squared. So we can see that this, if you can recognize it, so we still have the 3x, but this is x plus 5 quantity squared. And you know what, if you're not sure, if you're not recognizing these right away, that's okay. You could have FOILed it to say, let's see, x times x is x squared, 5 times 5 is 25. Oh yeah, look, 5 plus 5 is 10. And I happen to see that it's the same, so then you can change it to this format, x plus 5 squared. So it's quicker if you can start recognizing them, but if you can't recognize them, that's okay. You can just use FOIL and it works. All right. As I'm talking about recognizing, guess what? I'm going to give you some more things to recognize, because now that we're not dealing just with squared terms, we also have, some formulas for the sum of two cubes or the difference of two cubes. Remember when we had the sum of two squares, x squared minus, or the difference of two squared, x squared minus b, or a squared minus b squared. That was the a plus b, a minus b. So if you've got a cubed plus b cubed, you can pull out an a plus b, and then you have a squared minus ab plus b squared left. All right? If you've got a difference of two cubes, a cubed minus b cubed, you can pull out an a minus b, and then what's left in there is a squared plus ab plus b squared. And if you're not sure that I'm telling you the truth, multiply it through, and then when you put this negative b in there, those middle terms are going to drop out, and you end up with just the a cubed minus b cubed. All right, so here's just a couple more things to start recognizing. So what we can do here is say, oh, well, looky here. 27 is a perfect cube, 3 times 3 times 3, and x cubed is a perfect cube, and 125 is 5 cubed. 5 times 5 is 25, times 5 again, yes, is 5 cubed. So I've got the sum of two cubes. So I can use this formula and say, well, a plus b, what is the perfect cube of each of these? Well, we said this is 3x plus 5. So our a is 3x and our b is 5. And so now we're going to put in ax squared is going to be 3x squared. So 3 times 3 is 9x squared minus ab. So you're going to multiply a times b. So you have 3x times 5 is 15x plus b squared. And our b is 5. So 5 squared is 25. And that's as far as that will go. So if you have a perfect cube plus a perfect cube or a perfect square minus a perfect square, it'll go that one step. And if you remember that step, then you're done. All right. One more type of factoring that's different from the trinomials. If you have 4 terms, you can group those together and then factor out what will factor out in those groups. So you can kind of group together these two and these two. Remember, it's adding in between. So we can look and see, well, 27 and 45 have a 3 in common. Oh, they have 9 in common. So let's pull out 9. And they also have t squared. So 9 times 3 is 27, so 3t is left. Plus 45 times 5 is 9, and t squared times 1. So 3t plus 5 is what's left. And then what I can factor out from here, there's nothing in common with the 3 and the 5 or t's, but they both are negative. So I can pull out like a negative 1, and I can either say negative 1 in between there or just say minus, because that multiplies that minus a negative 1 throughout the whole thing. And so then I have 3t plus 5. The reason that's helpful is now both my 9t squared and my negative 1 are multiplied by the same thing. So it's like they're distributed out. So we can undistribute them and say, well, if both of these are multiplied by both of these, let's just call it 9t squared minus 1 times this 3t plus 5. All right? So that probably is the first time you've seen something like that. So if you need to go back and look at it again, do that. Do a couple of the guided practices. So it's really cool when once you catch on to just group them together and pull out just in the first two and then the last two what is the same. And then if you end up with the same binomial that you're multiplying by, then you can pull that binomial out and have a binomial times a binomial. All right, so let's see. What was I going to talk about next? That was grouping. Oh. So sometimes it's helpful to, in your mind, use the quadratic form. And we remember the quadratic form was ax squared plus bx plus c. Sometimes you've got larger exponents than that, but if you can kind of in your mind break it down into a form of x, and so that you've got something squared and something and then a constant, then you can break it down further. So I'll show you what I mean with this one. If you've got 10x to the 4th minus 10, and you're using your steps, and okay, well, we see that 10 is in common, so we pull out a 10, and what I have left is x to the 4th minus 1. And if you can look to see, oh, well, x to the 4th is the same as x squared times x squared. So in this case, and this is a confusing way to say it, because the u would be the x squared. All right, so this is actually x squared times x squared. So what we can do is we can split that up into, well, x squared times x squared is x to the 4th. And this is minus 1, so you're going to have a plus 1 and a minus 1. Do you see how I got that? So x squared times x squared is x to the 4th. So then once you get there, you can say, oh, well, so at every step, you're going to ask yourself, is this completely factored? Is this all the way factored? So once you get to this step, you can say, yep, 10 is factored. Yep, that's factored. Oh, This is a perfect square minus a perfect square again. So we got rid of the fourth, but now we still have squared. So this is x plus 1, x minus 1. Don't lose any of these factors. So this is the completed factorization of 10x to the fourth minus 10. Huh? Check that out. All right. Let's see. One more? Is that what I was doing? Oh, yeah. Let's do one more. Let's do the same type of thing. 3m to the 12th plus 54m to the 7th plus 51m squared. All right. So step 1 is to take out anything that's the same. 3 will come out of all of the coefficients, and m squared will come out of all of the variables. And at this point, if you think, yeah, I think I know where she's going, go ahead and pause it and do it and then come back, all right? Can you do it? Did you do it? Hope so. All right, here we go. Did you pause it and do it? I hope you have an answer. Here we go. Pull out the 3m squared, because that's what they all have in common. What we have left then is m to the 10th plus, oh, nuts. 3 is 18, is that right? No, yes. 3 times 8, that can't be right. 3 times 8 is 24. Okay, m to the 5th plus 17, 7, 7 is 21, yes. And, no m's because we took m squared out, so we're done. All right, this is where the whole, you don't have to think, if the u confuses you, that's okay. It kind of confuses me, but what you're doing is you're looking for what is the form of x that is squared. So in this case, you've got m to the 10th and an m to the 5th and no power at all. So if you look to see, oh, well, this is actually m to the 5th squared because there's 2 m to the 5ths in there. And this m to the 5th then would be kind of like your u, okay? So you keep the 3m squared, don't lose it. And now this you can factor further by saying, well, m to the 5th times m to the 5th is m to the 10th. And that will give me a middle term of m to the 5th. So now I want to multiply together to get 17. Well, it's prime, so it has to be 17 times 1, and it's positive, and this one is positive. And so 1m to the 5th plus 17m to the 5th is 18m to the 5th. So then we look to see there's nothing squared or even in an even exponent. So this would be as far as we can go with our factorization there. All right. So the last thing we have to do now is just solve. Let's solve them. So so what we're going to do now is we're going to have an equation. And remember, you set that equation equal to 0, so get everything in the quadratic form. So I've got 2x to the 5th. Oh my goodness. 2x to the 5th equals 12x to the 3rd minus 16x. So step 1 is to get it all equal to 0, right? So I want to keep my largest, my first term, my largest term positive. So I'm going to move these, so minus the 12x cubed and add the 16x to both sides. So I'm going to end up with 2x to the 5th minus 12x to the 3rd plus 16x equal to 0. Now, what I need to do is just follow my steps. Factor out a monomial. Let's see, a 2x will come out of there. So we have x to the 4th minus 6x squared plus 8 equals 0. And then thinking in terms of that u, we've got x to the 4th would be the same as x squared times x squared. So we can factor this further and say, well, let's see, x squared and x squared. This one is negative and this one is positive, so they're both going to be negative. And 8 is 2 times 4, and 2 plus 4 is 6. So we factored that out. And then are we done? Well, we look and make sure. That's as far as that will go. That's as far as that will go. Oh, this is a perfect square minus a perfect square. So you got to keep going. So keep these. Don't lose anything. X squared minus 4 is going to be x plus 2, x minus 2. All of those multiplied together give you 0. So if that's the case, then if any one of these factors is equal to 0, then the whole thing is equal to 0. So this is where you simply set every single one of these factors equal to 0. Set each factor equal to 0 and solve. So 2x equals 0, x squared minus 2 equals 0, x plus 2 equals 0, and x minus 2 equals 0. So as we're solving each one then, so divide by 2, so x equals 0. There's one solution. Add 2 to both sides. X squared equals 2. This is one that you have to take the square root. So x equals 2 or negative 2, right? Oh, but square root of 2 or square root of negative 2. That's why it's negative. There we go. So either it's the square root of 2 or it's the negative square root of 2. Either one. This one we subtract 2, so x is negative 2. This one we add 2, so x is 2. Whew. So our solutions for x are 0, plus or minus the square root of 2, negative 2, and positive 2. That is our solution set. And you can know if you've got at least the right number of answers because your largest exponent tells you how many factors you should have. So 1, 2, 3, 4, 5 answers. So when you get to the very end, you should have the same number of answers as you have in your largest exponent. All righty? Okay, I know you're not going to be happy about this, but we're going to do one more. We're going to do a word problem. Yay! Woohoo! We love word problems. All right, you're building a basin for a fountain in a city park. The sides and the bottom need to be 1 foot thick. The outer length is going to be twice the outer width and twice the outer height. You want to know, well, what are the dimensions of this if it holds 36 cubic feet of water? So you'll know that you've got to start with a formula. And you're looking for, you've got a basin that is a rectangular solid. So you want the volume to equal length times width times height. And so you plug in the parts you know. You know your volume is 36 cubic feet. That's how much you want it to hold. The length, the outer length is twice the outer width and the outer height. So you've got the length is going to be twice the width, and the width is going to be W, and the height is going to be the same as the width. Alrighty? So the only trick here though is, remember you've got this basin and the sides and bottom are going to be a foot thick. So you're not going to just multiply those together. You've got to look to see, okay, the length is 2W minus a foot for each side. So 2W minus 2. The width is going to be the W, but it's also going to be minus a foot on each end. And the height is going to be the W minus 1 foot just for the bottom, because there's not a foot, you're not going to close it in. So W minus 1. Alrighty? So now to solve it, you've actually got to multiply through first and then divide it by back out. Oh my goodness. So you can do this. And actually, I think it'll go quicker if I just look at what I've already done. So if you multiply through your 2W minus 2, so you've got 2W squared minus 4W minus 2W plus 4. And then you combine like terms. That's multiplying these two together. Then you multiply that by the W minus 1. So you will end up with, once you multiply it all out, you're going to get 2w cubed minus 8w squared plus 10w minus 40. Oh, wait. I said minus 40 because I took the 36 already. So we're going to be minus 4. And then when you subtract 36 from both sides, now you've got 2w cubed minus 8w squared plus 10w minus 40 equals 0, because you have to set it equal to 0 in order to factor out. And in this case, I like grouping. In this case, you've got 4 terms, so group them. So you've got 2w squared here times a w minus 4. And this is going to be 10. 10 coming out. And this is going to be w minus 4. Yay! I like it when it works. So now we've got the w minus 4 comes out, and 2w squared plus 10. And that's as far as it will factor out. But we should end up with 3 answers. So here we go. This equals 0. So we've got this one equal to 0. 2w squared plus 10 might be equal to 0. W minus 4 might be equal to 0. So solve minus 10 and divide by 2. So w squared equals negative 10 halves, which is negative 5. And if we take the square root of a negative 5, we're going to have an imaginary number. So in this case, can we have an imaginary number? Not when you're building a basin. You don't want anything imaginary about that. So this is not going to be a plausible solution to our problem. So when we add 4, w equals 4. So our width is 4, our height is 4, and our length is 8. So 8 feet by 4 feet by 4 feet are the dimensions of our basin. Very cool. Okay, I'm making sure that I got the right answers because that would be very embarrassing. Ta-da! Okay, thank you very much. Have a great rest of your day, and I'll see you next time.